All right, what I want to do is show you how you can use SketchUp to calculate the path of the moon and to verify these models that I'm making. Now, SketchUp is free and it's easy to use, and I'm going to show you exactly how to do it so you can use this video as a tutorial for yourself to be able to do it. Now, when you open up SketchUp, this green light right here is north. This red line is east. Then you have the dotted red, which is west. You have the dotted green, which is south. And the blue line is your vertical axis. So the solid blue up like this is above the plane, and the dotted blue is below the plane. Now, the first thing that we want to do is decide how big we're going to make this circle down here. And that has to do with our visibility. So we're going to go to the distance to the horizon calculator. And for simplicity's sake, I'm going to use 6 feet as our observation height. And that creates a distance to the horizon of 3 miles. This is just easy to work with. Now we're back in SketchUp, and we're going to use the circle tool to make a radius that 15,840 feet. Now I'm dragging along the red axis here because SketchUp doesn't make a perfect circle. It's segmented. And when you drag along this, it means that the segment's going to hit right on the red and green axis. So if I came off like this, you can see that the segment's not going to hit right on the red axis, but by dragging along the red, it will. So now, before I've clicked, I'm going to type 15,840 feet, hit enter, and now it's exactly 15,840 feet. That means that this radius is 3 miles here, this radius is 3 miles. So this is our 6-mile diameter bubble that we can see, as the observer. Next, we need to know what angles we're working with. So you can go to a site like timeanddate.com. I've got Austin, Texas, because I'm going to be showing you some footage that I recorded yesterday. So just go, to the city nearest you and go to the date that you're recording. Now, I recorded yesterday morning. So the moon actually rose on the 19th at 11:04 p.m. at an angle of 73 degrees. And it set at 12:35 p.m. yesterday at 285 degrees. And at 5:52 a.m., the meridian passing was at 73.1 degrees. So these are the angles that we're going to be using, the 73, 285, and 73.1. So we're back in SketchUp, and I'm going to show you how to set these angles on this circle. And what you do is you grab the protractor tool, and you'll see that as you move it close to the origin, it's going to sort of snap into place. Once it's in place, you get that origin sign there, do a click, and that's what's going to hold the protractor at that spot. Now what we want to do is set the angle that we're going to be measuring from. We want to measure from the green axis. That's north, that's 0 degrees. So we're going to click here, and now this is going to be setting our angle. So as we drag this around, what we can do is just type 73, hit enter, and right there it's at 73 degrees. Now the protractor is free again, so we're going to snap it to the origin again. Come up here, we're going to measure from the green axis. We're going to bring this all the way around like this, and you can see that the angle is getting close to 285. Let's just type 285, and there. That's going to be where the moon rose and where the moon set. Now the next thing that we need to do is put in our meridian passing angle, but there's something that you need to consider with this, so let me show you that. So here it says, it's 73.1 degrees. Now what time and date doesn't tell you is whether or not this 73.1 degrees is the moon being south or north of you. It just gives you this angle. So what you can do is you can go to MoonCalc, and here I've got Austin, Texas, and you can see that the moon is south. All right, I'm in the northern hemisphere. I'm at 30 degrees. This isn't a problem if you're north of the Tropic of Cancer. It's always going to be south of you. But if you're doing this between the tropics, or you're doing it in the southern hemisphere, you can come here and you can see whether or not just drag this, and you can see whether or not that angle is north or south of you. So back at SketchUp here, I'm going to show you how I do this. I'm going to grab the rotate tool and I want to line this up a certain way. So I'm going to move this around. I'm going to get that green line parallel with the horizon. You can see that the red line is going to come in line with the blue vertical axis, and I'm going to make this sort of flat. Okay, so now what I'm going to do is grab this pencil tool for drawing a line, come here from the origin, I'm going to pull it up along that blue vertical axis, and I'm going to go 15,840 feet, and there we go. Now what we need to do is select that line, the line is selected. We're going to grab the rotate tool. We're going to bring it down here. It looks like a protractor. Now if it lays down flat like that, what you need to do is take this and rotate it a little bit flatter. And now it's going to stay vertical. We're at the end point, so we're going to click there. We're going to come up here on our line, click again, and now when we drag it, it's going to move the line along the plane of that green, the north and south. So we need to set this angle. Now what we're going to set that angle at is, because we started clicking on it at 0, what we need to do is a little subtraction. We're going to take 90 and minus the 73.1. We have 16.9 degrees that we're going to adjust this to. So let's go back to SketchUp here. We're going to do 16.9, and there we go. That's going to be our meridian passing. All right, so we've got our meridian passing line here. Here's our moonrise angle, our moonset angle. Now what we're going to do is rotate this around. Remember, this green line is north, so keep your orientation. We're going to bring this around, and we're going to line it up right about here so that we have a pretty decent side view. Now there might be better ways of doing this, and if somebody can show me how, that'd be fantastic. I'm using the 2-point arc. So I'm going to come down here, start at that intersection right there, click there, click at the top here, and you're going to see how this line flops around a bunch. Now this is the trick, getting comfortable with how this arc is made. After you've done it a few times, it gets a little bit easier, but it's still right about there. See, this is coming up a little off. Well, no, maybe not. I might be right. There should be a little bit more bow outwards. Let me try this another time. Click down here, up here. There, that's better. All right, so I'm going to play around and get the next one done. You don't need to watch that. I just wanted to show you it's a little tricky getting that. Let me show you what it looks like with the second one in place. So here I've got the second one in place. Let me just show you around this a little bit. We've got north towards us. We've got a 73-degree angle here, 285 here, 73.1 for the meridian passing. You can see this red line. I'm going to line that up, camera view. You see that angle from the side. All right, that's what you're looking for. That's pretty close. That is path of the moon, November 20th in Austin right there. Now what I'm going to do is I'm going to take the select tool. I'm going to click on this side because my footage yesterday started at 9:55 a.m. and I want to figure out where in this arc 9:55 is. So now that I have this selected, I'm going to right click and I'm going to go to divide, and now as I move the cursor it's going to divide into segments. I'm just going to type 6. This is half of the arc, so that, okay, so now I've deselected, and now that you'll see when I click on this, it's been divided into 1, 2, 3, 4, 5, 6 segments. So this would be for a perfect 12 hours of the moon being up. Now, yesterday, I think it was 12 hours and 31 minutes. So this isn't going to be exact, but it's going to give us an idea of where in this arc this footage starts. So let me show you. Once again, moon rose at 11:04 p.m., set at 12:35. What is that? 12 hours and 31 minutes, I think. My footage is at 9:55. Let's make this, let's see, that if it's 10 o'clock, it's 2.5 hours. 2 hours and 10 minutes before moon set. So 2 hours and 10 minutes, that would be an hour, it's 2 hours. So right about here is where my footage starts, right here. So let's line this up. Remember, this dotted red line here is looking due west. So for the observer down here, which was me, my footage begins right about here. So what I want to do is I'm going to line this up. I'm going to take a snapshot of this. I'm going to use this as our angle to compare to the moon footage and see if it's following the path that I modeled up. So I'm going to use a screenshot of this in the video towards the beginning. This is the path of the moon, the way I model it up, and we're going to be comparing actual footage to see whether or not the moon follows along this path. But this right here won't work for all the footage. So what I'm going to be doing is I'm going to be measuring the angle of this line and just putting a whole bunch of these lines that go all the way through the full screen all along each other, so that we'll be able to follow my footage of the moon traveling and compare it against a whole bunch of these lines. That'll just make it the easiest. So let me show you how I'm going to get the angle of this arc here. Get your orientation. This green line is north, dotted red right here is west. So this is the moon setting arc right here, and this is what we want to get a measurement for. So what I'm going to do is come here. I'm going to draw this line following the green axis. And extend it out this way as well. Now I'm going to change my angle, come in here, I'm going to grab the protractor tool. Sits right there real nice now, following that green line. Come up here, and now you can see that down here it's 59 degrees, and then up here, here it's 59.2. This is that second hour segment, and we've got about 2 hours and 10 minutes of footage. So 59.3 degrees is where it starts, and then towards the end it's 59 degrees. Let me show you how I'm going to make a bunch of lines at 59.3 degrees. I'm in a new sketch up here. So this green is north, dotted red west. Sort of line this up in the middle right here. Grab the protractor tool, set it out at the origin. I'm going to snap off of the green axis here, come up to 59.3. There it is. Now what I'm going to do is zoom out a bunch so we have nice long lines to work with. Let's get this back in the middle a little. So I'm going to draw some lines here, or at least one line. Okay, so there's a nice long line. See that? Now, for copying this, I'm going to hit the move icon, and on a Mac I'm going to hold the Option and get that plus sign. So I'm pulling another line off of that. They're going to be separated. You see how it says on green axis? That means that I'm following that same north-south right there. I'm going to click there, and now I'm going to hit, let's say 100, and then I'm going to put X, hit enter, and there. Now we've got a bunch of lines to work with. So what I'm going to do is just make sure that I've got this straight, and I'm going to take a screenshot of this and use this as an overlay in the video to see if the moon's following this path. Now first off, I'd like to say that I recorded this with a Nikon D3200. It's an older camera that I have, and I intentionally did this for making the point that you don't have to have a P900 in order to do this. The D3200 has a lens that goes from 18 to 55 millimeters. Okay, so maximum zoom 55 millimeters. The P900 is 2000 millimeters. So there's a big difference there, and I just wanted to show that your typical camera can record this. So here's what the 55 millimeter zoom on that D3200 looks like. And take a note of the time date stamp here, because I'm going to speed up the rest of the footage, and the time and date stamp's not going to work anymore. Now I'm going to show you that screenshot overlaid that has the arc of the moon that I modeled up in SketchUp. And you'll see that this doesn't work too well as far as being able to watch the path of the moon along the arc. So then I'm going to go to all the lines that I put out. So here's an overlay with a bunch of lines all set at 59.3 degrees. I've adjusted the opacity so that you can see through and see the moon traveling. So you can watch it follow the lines here. I'll speed up the footage now so that this doesn't take forever, otherwise it would be over 2 hours long. So I'm going to crank up the speed and follow this. Just remember that the angle of that arc changes a little bit. So it's 59.3 right now, these lines. And then the end footage, I should have the lines adjusted to 59 degrees to be following that model. So this is sped up footage now. This is 18.6 minutes of footage condensed down to 1 minute. And you'll see that it follows the line very closely. It's not perfect, but it's pretty close. Here's another 20 minutes sped up, condensed down to 1 minute, and you'll see pretty much the same thing. It follows this angle pretty well. Here's another 20-minute section condensed down to 1 minute. You'll see about halfway through that the camera did get bumped and it jumps over a little bit, but it doesn't really affect anything because it follows another line. Now this isn't perfect, but it's following this angle pretty close. And here's another 20 minutes of footage condensed down to 1 minute. Once again, still following these lines very closely. Now here, I switched to the P900 because yesterday I was recording on a day where the moon disappears before it gets to the horizon. It fades out, and you'll see that in the rest of this footage that it's going to disappear. I'll show you at the end what it looks like without having this overlay. Um, so this is now P900 footage. If you're filming the moon at night, you won't need to have a P900. It's just during the day when it disappears at the horizon. So just something to keep in mind, that you can do this with nighttime moons with a camera that's not a P900. Here's another 15-minute section with the P900. Now I'm just going to leave all these lines at the 59.3 degrees. I don't know where to change it and adjust it. This is just to give you an idea how to do this. You can be more exact and model it up perfectly. This is just more of a tutorial on how to do it. And then this is the last 15 minutes that I'm going to do with the grid lines up. It's condensed down to 1 minute. After this segment, I'll play the rest of the footage without the grid lines, and you can watch the moon disappear. So the rest of this footage is without the grid lines, and it's 8x speed, and you can see that the moon is severely disappearing. And you know, the trees that you see here, these are tall trees. They're probably 50, 60 foot tall, and so it disappears long before the horizon. It's been disappearing the whole time, actually, but it'll be gone before the horizon. So let me show you the problem we run into if we try to model this up over some sort of an AE map where the sun and moon do circles. Here's the Gleason map, which is real popular. And so from this origin point out to the equator, on here, it's 19 feet. And we know that the Gleason map, that this radius distance from the North Pole out to the equator is 3,955 miles. So since this is 19 feet, and what we want to do is figure out how high to set a 3,000 mile high sun or moon, when you do the cross multiplication, it comes out to 14 feet and 7/16. So I've got a point marked here. Now what I'm going to do is I'm going to draw a line from that North Pole extending out through the Austin area like this. Now I'm going to zoom in and use the protractor tool. Austin would be around this area right here. I want to set this at 90 degrees. All right, so that's our east and west, north and south in Austin. And while we're at it, I'm also going to set our 73 and our 285 degree moonrise and moonset. And now I'm going to spin around here, put a vertical line going on that blue axis. I'm just going to make this excessively long. Now I'm going to select that line and bring this position a little bit more flat. Grab the rotate tool, click on here, and tip it 16.9 degrees. All right, so here is our meridian passing angle right here. We're going to spin this. We're going to get top-down view. This is our 3,000 mile high scaling mark. So I'm going to take the circle, and because it's blue right there, it means that it is going to draw a circle perpendicular to the vertical axis. I'm just going to make this a nice big circle here. Come around, and you can see where that penetrates right there. So I'm going to take the circle tool and come right out to that. We're at the intersection. Now I'm going to trim off the extra circle here. All right. So here's a fun thing in SketchUp, the push-pull tool. So we're going to click on this. We're going to drag a cylinder down to being on the face of the image. Now I'm going to get rid of the top and the bottom. All right, so now we can see what's going on here. So if the moon is 3,000 miles high, and this is the scale right here, 3,000 miles, and I'm seeing it at 73.1 degrees at the meridian passing right here, then for it to rise at 73 degrees and set at 285 degrees, I would have to see the moon all the way out here, because any place short of that along this circular path, and I wouldn't be seeing it at 73 degrees. This right here. Let me draw a vertical line from this point. It'll snap blue there. All right, so here's Austin. For it to rise at 73 degrees, I'd have to be seeing it over here. Same is true over at the 285. I'd have to be seeing it to here. We don't see that far. We see 3 miles to the horizon. All right. This doesn't work. There's so many different ways that I can model this that I can show you that it doesn't work. The amount of ways is innumerable. It just, because then this is just for Austin. It becomes, and this is just one day. There's so many, and this is a very kind day to look at as far as the angles, because I can show you through the calendar that there's a lot of days that the angle's much more severe. All right, we got angles like this, setting like this, and this is for a city in the northern hemisphere. I don't want to make this video too long. We could look at cities in the southern hemisphere, and that totally destroys the idea of the sun and moon doing circles, because their angles are reversed. They're the other direction. The northern hemisphere is the one where things sort of work, but in the southern hemisphere, the angles go this direction, and you've got moonrise over here and moonset over here. All right, one last look at this. I put in the arcs from the moonrise angle to the moonset angle, and all right, so if we're talking about perspective of seeing the sun and moon doing circles around some sort of AE map, one, I'd have to be able to see all the way out here to the middle of the Pacific and the middle of the Atlantic Oceans in order to see the moon rise at 73 degrees and set at 285 degrees. I can't see that far. I can't see California from Austin. I can't see the East Coast. And I definitely can't see out into the middle of these oceans. So that's not possible. And then this angle right here, if you come in here, I measured it up. And this angle right here becomes a 65 degree angle. That doesn't work. If I had 65 degree lines on the grid, the moon would not be following this path at all. And then the other thing is this apex. When you film the moon at the meridian passing, it doesn't come up at a steep angle, peak out, and immediately come back down at this steep angle. It doesn't happen. What you'll see is the way I've modeled it out, comes up in that round arc, and it's traveling just about perfectly horizontal for a number of minutes, quite a few minutes. It's very, very horizontal, and then it starts to slowly descend again. So we can continue to analyze footage against my modeling. This right here is showing me that sun and moon aren't doing circles, and that it's very local. You know, if for a person the eye level is 6 foot and can see 3 miles to the horizon, it's all happening within that little bubble right there for you.